Afternoon. We're very excited to kick off our 2025-26 Lunch and Learn series. The first Lunch and Learn we will be having is on roundabouts. Just some quick housekeeping notes. This is a hybrid meeting, so we do have some folks in the room and some folks joining online. This meeting will be recorded for documentation purposes. And for those in the room, the two speakers on the table are also the cameras and microphones, so please keep side chats to a minimum as the microphones can pick up whispers. Thank you. So I'm very pleased to introduce Scott Bushee from Connecticut DOT. He is the Transportation Principal Engineer leading the State Highway Design Unit. He has a BSCE from the University of Hartford and is a licensed professional engineer in Connecticut. He's been with CTDOT for over 30 years and is chairman of the Highway Standards Committee, Complete Streets Committee, and Roundabouts Committee. Mr. Bushee is most known for leading the design of 6 roundabouts on state roadways, a roundabout corridor in Norwich, Connecticut, and multiple multi-use trail designs, including the Farmington Canal, Heritage Trail in Cheshire and Plainville. He has led interstate highway interchange designs, many intersection safety and operation upgrades, and numerous roadway designs involving general safety improvements, complete streets initiatives, and upgrades for a state of good repair. Thank you, and I'll turn it over to Scott.
Just a quick introduction, guys, and I got a sore foot, so I can't stand up for too long, but you see me, and I'm sure you'll hear me. Thank you for the introduction, Kate. That was great. As we think about safety, things that are important to us: safe pedestrian facilities, slower speeds, roadway safety, and better traffic operation and efficiency. And those are often, as transportation officials, the things that we focus on when we're looking at overall safety on our roadways and communities. I got a quick video here I want to share with you, something I got exposed to from Federal Highway a few years ago. It's a cartoon, but this is a lunch and learn, and I think we can have a little fun. But I want you to think about these topics while you're watching the cartoon. It really resonated with me, and it's something that you'll all remember. And I think it's very interesting that Walt Disney thought of these topics almost 80 years ago when they built the cartoon. Got the idea, right? Mr. Walker is the pedestrian, Mr. Wheeler, the motorist, and we still have these problems here today that Walt Disney thought of almost 80 years ago. Over 43,000 traffic fatalities on a national trend. When you look at pedestrian safety and bicycle safety, what we call our vulnerable users, basically anyone that's not in a motor vehicle is a vulnerable user. Could be somebody in a wheelchair, someone push a baby carriage. 6,300 pedestrians are killed annually, 900 cyclists, and in 2022 it was up to 7,500. The trend here is progressing significantly higher at a very fast pace, and the reason is speed. Speed is the reason we're having so many fatalities. In Connecticut, over 300 fatalities a year on our roadway systems, been averaging recently. Federal Highway has something called Safe System Approach. It's a 5-tiered wheel, and as transportation professionals, the ones that we focus on the most are safe speeds and safe roads. Those are the ones that we can have the most influence on. We can also look at safe road users through education, but we're primarily safe roads and safe speeds in that mission. And roundabouts are a tool to get us where we want to be. So we'll take a look at that. In Connecticut, I've got 10 here. We just finished our 11th roundabout on the state system that Connecticut DOT has built. Significant success with those. We reduced injuries on average 71%, crashes by 47%. And that trend goes up and down a little year to year as the crash data comes in. A few years ago, the injuries were reduced. I think it was up to 80%, but incredible success. And we line up pretty close with the federal highway trend. Something that's very important if you're going to initiate a roundabout is community education, right? Everyone needs to understand the purpose and need for the roundabout, how it works, the roundabout features. And if you don't get that out there, these are the types of things that can happen. This cartoon was actually directed at me. I was the designer on this roundabout when it first came out. And it was a little bit hurtful when it first came out in the newspaper as the person that spent 3 years of their life working on this roundabout project, getting it built. But after about 3 months, the community understood why the purpose of the roundabout, how it worked, and this really wasn't the trend anymore. But when it first opened, there was enough misunderstanding of how it worked that this was the attitude locally for a few days. And we saw that repeated in West Hartford recently. So make sure that you educate your community, your team that you want to think about, your municipal leaders, especially emergency services. You cannot have a successful roundabout project if you don't have the police chief behind you and the fire chief. Very important. Public works for maintenance purposes, and your business owners. We don't always think of them as part of the team, but they're the ones that are working with the community. They engage the community the most. So if they're positive about some change in the community, they could spread that through their business interactions. Make sure you engage them. Roundabouts are circular intersections, improve safety for all users. They reduce traffic congestion. Slower speeds, 15 to 25 miles an hour. There's no left turns at roundabouts, fewer decisions to make. You have less conflict points, less pollution. That's what makes them so good. When you compare roundabouts to traffic signals, signals tend to create more crashes. You have the signal going red, people are inattentive, they're not paying attention, you end up with rear end crashes. People get in a rush, they try to beat the light, maybe they make a left on red trying to clear the intersection, you end up with these angle crashes. And most of all, the signals don't address high speeds. I have a lot of people from the community meetings that come to me and say, Scott, why don't you just put in a traffic light, it'll solve the problem. Well, the light is green and it doesn't address speed. So your pedestrians are still crossing at higher speeds. And if there is a crash, it happens at a higher speed. The signals also tend to be a lot less efficient in the off-peak hours because time is assigned around the intersection at certain phases. And it's very limited as to who can access the intersection at one time. When you start thinking about maintenance costs and we look at electrical systems and computer systems with signals, these have to be replaced every 15 to 25 years. These are an inherent maintenance liability that are very, very expensive that you don't have with a roundabout. So there's a lot of benefits to roundabouts. When you look at the environment, 24,000 gallons of gasoline was saved in Indiana, and in Virginia, 10 roundabouts saved 200,000 gallons of gasoline in their community. So certainly a big environmental benefit from that. And in terms of operation too, and not having emissions from these vehicles, the roundabouts tend to be much, much more efficient, especially in the off-peak hours. Now, the trend in roundabouts has been progressing significantly. They really got started in the US sometime around 2000. That's really when they've really first started coming out. Connecticut DOT got involved about 2005. We built our first roundabout maybe around 2007 or 8. But we got over 10,000. I think it might be up to 11,000 now in the US. But the Northeast predominantly is where most of them are, except for California and Florida. We now have 11 on the state system. I'm estimating about 30 on the municipal roadways. This map is not 100% accurate because we don't have the best reporting system. It's really word of mouth, and if people let us know, we throw it on the map. I know there's one in Stamford that just opened that's not here. The one in Naugatuck is not here. And the one in state system in Haddam we just finished last month needs to be added, but you get the general idea. So comparing roundabouts to old rotaries or traffic circles, this is not a roundabout. We have senior folks that refer to these as roundabouts from time to time, but this is not a roundabout. This is a traffic circle. And the difference is high-speed entries, circulating traffic, when these were initially built, had the right of way, right? So circulating traffic would initially yield to entering traffic. That was subsequently changed. The yield was put on the approach to crashes, but you get a lot of weaving, lane changes. The worst with these are the higher speeds. This is what a modern roundabout would look like at that intersection. And this is in Connecticut. This is Stonington on Route 2, still there, but if that was converted to a modern roundabout, that's what that would look like. And that the speeds would be substantially slower for improved safety. Modern roundabout features, we have the truck apron, which is very important. That's what the rear wheels of the truck go up on. We have splitter islands on the raised approach. We have crosswalks. We have yield signs. Very important features in a roundabout. In practice, you can see the truck apron here. That's what the rear wheels on a tractor trailer ride up on as they go around it. That allows us to keep the circular roadway narrow for motor vehicles. The landscape island, you can see here, a lot of folks, we call that aesthetic, right? And plantings, but to me, that's safety. You can see that from a distance. You can see things with vertical objects from a distance, and that helps with the traffic calming. So I strongly recommend the landscape features. Our design manual is NHRP 1043. This is the third manual on roundabouts to come out in about 20 years. And the sense there is we're constantly learning, we're growing knowledge, we're progressing, especially when it comes to multi-lane roundabouts. So we try something and we learn from it, and then we revise the manual based on what we've learned. And that's going to continue for some time, especially in multi-lane roundabouts. Now, some things to really look at if you're doing a roundabout review, maybe concept work, is alignments. This is one of the most critical roundabout design features in terms of overall safety. So if you have left aligned, that means the roadway coming into the roundabout is to the left of the center of the circle. And that gives you the best deflection, the best speed control coming in. You can use center aligned, where the center of the roadway matches up with the center of the roundabout. Generally, it's a larger diameter roundabout. It requires more real estate because the diameter of the roundabout has to be bigger to get your overall deflection. What you absolutely don't want is right aligned. That means your approach roadway lines up with the right side of the roundabout, and you're going to have very, very high speeds. This is a fatal error in roundabout design. And here's what that looks like in practice. So here's an example of that in practice. And on paper, it may have not been noticed, but as that's built, we're going to get pretty high speeds through that intersection, right? So that's what's to be avoided. And I think it's pretty clear the goal that we're looking for here is speed control for safety. And we're just not going to achieve that with a right aligned roundabout. Roundabouts have reduced conflict points over traffic signals or stop controlled intersections. Roundabouts have 8 conflict points because it's right in, right out. There's no left turns. When you look at a traffic signal or stop controlled intersection or 32 conflict points, those are areas where you have vehicle path overlap. It's predominantly related to vehicles making left turns. Left turns from all these roadways cross other paths, and they're crossing in front of vehicles at extremely high speeds. And that's where your crashes become severe and you have injury crashes. So 75% reduction in going to a roundabout, often 40 to 50% reduction in speed can be achieved when you go to a roundabout. And looking at this example, this is in Granby, Connecticut. Looking at the roundabout compared to the conventional intersection, it's very clear, which one's going to be safer just because of the geometry. You've got that high-speed rural arterial, likely speeds over 50 miles an hour on that. With the roundabout, you're going to be 15 to 25 miles an hour. And that's where we want our communities to be, safe. Here's the speed reduction coming into the roundabout. This is my preference on design. It's a chicane type design, kind of forces a little bit of curvature on the approach to the roundabout. But if you look ahead, the driver's view of the roadway is cut off. It's cut off by the chicane and it's cut off by the central island of the roundabout. You don't have that appearance that the road just goes straight through. And that's what promotes traffic calming, gets people to slow down. I also like the street trees. I think they're an important safety component. It's just not aesthetic. That limits the visual corridor that the driver's looking in, and it tends to promote traffic calming. So love street trees. Yield on entry. What's important here, double yield signs on the entry. Right and left yield signs. The one on the left is optional, MUTCD. Strongly recommend doubling up the yield signs. Works very well. Landscaped islands and gateway opportunities, I strongly recommend them. I like flagpoles, municipal gateway signing, tall landscaping, not large caliber trees, but tall landscaping, especially because it's strength, it's visual strength. People see that from a distance as they're approaching the intersection, and they slow down. That's something that gives us the traffic calming that we're looking for, reduce speeds. But something very critical in this as a design feature, not an aesthetic feature, whatever you put in the central island, take the time and the expense to put lighting on it. Ground mounted up lighting is what you want. Now, the conventional intersection, as you're approaching, if there's a traffic signal, you're going to see the signal, red, yellow, green. You'll see that at nighttime. Roundabouts are dark. You don't have the signal heads. So give that driver something to show them that the roundabout's ahead. And by illuminating your landscaping, by illuminating your municipal gateway signs, they can see that. And it's very helpful. Let me go back one slide. Okay. One of our first roundabouts in Connecticut, this was Killingworth, 8081. This was a retrofit. So this was an old traffic circle, kind of the low-hanging fruit, low expense, very high speeds through here. You're probably getting 40, 45 miles an hour. So we did a retrofit on that with moderate roundabout features. We get speeds down maybe 20, 25 miles an hour. That was a big success in terms of safety and operation. These are the vehicles we designed for on a modern roundabout. You've got a transit bus you want to check, and whether that's a transit bus or a school bus, very important that we keep the wheels of the bus off of the truck apron. They belong on the circular roadway. Anything with passengers stays on the circular roadway, does not go up on the truck apron. W62 type tractor trailer, that's the largest vehicle on a state road without a permit, and we should be designing for those. Very important. The lowboy truck, we have to consider that, hauls tall construction equipment. They're a design vehicle because of vertical clearance, not always because of horizontal offset, but vertical clearance. Those trailers are usually only 5 inches off the ground. So very important to check 3 dimensions for them. And of course, emergency services, fire. Generally, if you design for a WB62, the fire truck is always going to work, but I always do due diligence. I go out to the local fire department, I check their truck, I measure it, and we just make sure that we're going to accommodate them properly. Now, here's a WB62, and what that means is 62 feet from the front axle of the truck to the center of the rear axle. That's the distance for the wheelbase. And what we should be designing for. This is the common tractor trailer on our roads today. And just, a word of caution, I've run into a lot of folks designing roundabouts that say, oh yeah, we're not accommodating the tractor trailer on that leg of the roundabout. They don't go down that community, or it's a no through trucks, right? It's even signed no through trucks, but just some things to think about. It might be a no through truck route, but somebody that lives in that area, if they get their pool filled and the water tanker comes to fill the pool, what's the truck? Probably a W62. If there's a large development getting built on that road and somebody brings construction materials to that development for the construction getting built, it's probably a WB62. If somebody's moving to California and a Modio Movers shows up in that community, the truck is possibly going to be a WB62. So you want to make sure that when this truck gets to your intersection and it's a roundabout, you know what's going to happen. It's very, very important. And this is how we design for that truck. We use auto turn performance software with our CAD. And if you look at this, you can see the rear wheels of the truck are on the apron. The cab of the truck is on the circular roadway, lines up with that picture to the left. That's how that works. Cab of the truck never goes on this truck apron. That's a poor design right there. Cab of the truck should be designed to go on the circular roadway. Only freight goes on the truck apron, never passengers. And here's how that looks in practice. You've got that tractor trailer going around, the rear wheels are on the truck apron, the cab of the truck is on the circular roadway, exactly how it should be. And this is what happens, folks, if you don't properly design for that vehicle, right? The failure to the left side of the picture, we cheated the buffer. We didn't have a lot of space. It was a downtown commercial area. We went with a 2-foot buffer instead of, we typically do 4 feet between the curb and the sidewalk. And we put the yield signs in there, and the mirrors on the truck overhang the curb. So when that truck is going through that curvilinear geometry and the mirrors are overhanging the curb, the mirror's taking out the yield sign. So you really need a 4-foot buffer to do that properly. And then we cheated, on the center island. We didn't really accommodate the 62 properly. This first one was designed for a WB50 prior to the 62 design vehicle becoming the state norm with a permit. But this is what happens, type of damage. And my point in showing this slide is that a 6-inch curb is not a deterrent to a driver of W62. That's a bump for them. And if they get in there and they get hung up, they're probably not going to back up gently and try to get out of it. They drop a gear and hit the gas. And this is what's going to happen. And being the designer on this, or the lead, and having to have the community come back and complain about it, you can't escape that eyesore. You can't escape that. So just due diligence on your design vehicle so that you don't end up in that situation. Very important. This shows the clearance topic I was telling you on the lowboy truck. It's very important to check these in 3D. They do come through a lot of our intersections. Here's the emergency services, no problem getting fire through there. Cars, very comfortable going through the roundabout, plenty of space. That one in Killingworth reduced crashes 57%, injuries 67%, a big success. Now, this location here came to me as a traffic signal request years ago. And we just knew for safety, because of the geometry there, fairly high speeds, the kind of the alignment of the intersection, the crosswalk especially concerned me with the length of crossing for our vulnerable users. The roundabout was the right choice here over a signal. We got deflection, we reduced speeds down 15 to 25 miles an hour, and we got good pedestrian infrastructure. That's, you know, that's our goal. That's what we want. Significantly better choice than a traffic signal for that intersection. It works great. Reduced crashes, reduced injuries 67%. Good safety success with that one. Now, when we think about our pedestrians in terms of safety, if you have a pedestrian get hit at speeds around 20 miles an hour, 9 out of 10 survive. Once you go into 40 miles an hour, those are our signalized intersections, a lot of them. Only 1 out of 10 pedestrians will survive a vehicle strike at 40 miles an hour. So we could save lives by implementing roundabouts and keeping that speed down in the 15 to 25 mile an hour range, especially. Now, how bicyclists use roundabouts, that kind of light blue line there, going through the circular roadway, that's the woman over on the right side of the picture. She's got the green jersey on. She's out in the circular roadway riding with traffic. She's confident. You know, the idea is be safe, be seen, don't cross in front of vehicles, ride with vehicles. And that's where I prefer cyclists to be. Works out very well. Now, someone for a novice cyclist, maybe children, they could take that blue line approach. That's the guy in the blue t-shirt. He gets off the roadway. He goes onto the sidewalk. He walks his bike as a pedestrian. That's the other route a person could take. Those are my preference. For cyclists, what I absolutely do not want to do is build a cycle track around the perimeter of the roundabout, because now you're putting bicycles in front of vehicles that are exiting to the right. And, you know, in the Netherlands, that's, you know, just, it's been a conflict. In other areas it's been tried. So either encourage people to ride with traffic in the circular roadway or exit the roadway onto a side path or a sidewalk. Now, pedestrians, they're gonna go off the curb ramp. They're looking to their left. If it's safe, they go out to the refuge area, and they're in the center, in the splitter island. They're gonna stop. They're gonna look to the right. If they get a safe gap, they cross the rest of their way and go. Here's that cyclist. This is on our West Haven roundabout, riding with traffic, no problem. Very, very easily and safely get through that intersection. And what I like seeing about this is they're not riding in front of vehicles. They're never crossing in front of a vehicle entering the roundabout. They're not crossing in front of a vehicle exiting the roundabout. That's the safest place for a cyclist to be. Now, another thing about roundabouts in terms of pedestrian safety that's very different than other intersections. At a conventional intersection, whether it's stop controlled or signal, the crosswalk is in front of the vehicle. It's in front of that operator that's making complex decisions. They're looking at the traffic light, trying to determine if it's green, can they go? They're looking at other vehicles approaching the stop sign. When is it my turn to go? There's a lot of data they're processing. What they're not doing is looking to their right to see if a pedestrian might step off the crosswalk at a point which they hit the gas and go. And you don't have those type of opportunities for conflict with a roundabout, because the pedestrian crossing is behind the lead vehicle. So that vehicle that's going to enter the roundabout, he's processing information, you know, he's yielding those vehicles a circular roadway and he's getting ready to enter the roundabout. He's not concerned about pedestrians. The pedestrian's always behind the operators making the decision, making pedestrian safety at roundabouts substantially safer than any other type of intersection. And here's how that works. You know, you're crossing behind the lead vehicle, making the decision. It's a two-stage crossing. You look to your left. If you got a gap, you go out to the refuge island. You look to your right. If you got a gap, you cross the rest of the way. These are short crossings. Always illuminate your pedestrian crossing. To the right here, I have a picture of illumination. That's front lit. That means the light goes in front of the crosswalk. If you put it on the back of the crosswalk, it creates shadows. So always front light your pedestrian crossings, very critical. Illumination is a very, very important part of roundabout design. It has to be done. It's not an option. It must be done. You have to have good illumination. Now, if there's one takeaway from today's talk that's the most important to me, it's sidewalks. Always build sidewalks at roundabouts. We never want to be in a situation where we said, oh, nobody walks up there. There's no destinations. There's no people walking. There's no pedestrians. At some point, there's going to be a pedestrian there, whether it's somebody jogging, somebody's car broke down, there's gonna be a pedestrian. In this case, I spent a lot of time in this location early on. In the early 2000s, there was no pedestrians, right? There was really no destinations. And then I went out there after we built the project. It was a half a day of school, and I see kids walking to the convenience stores to get ice creams and sodas.
Good.
And there's no sidewalks. So if you look at that truck in the roundabout, we talked about that before, where's the front bumper of that truck? It's almost overhanging the curb line. Roundabouts don't have shoulders. So that painted line, it's a visual aid. It's a white edge line. It has the glass beads. It reflects at nighttime. It helps guide the driver. It's not a shoulder like a conventional intersection. It does not have a safe space for pedestrians. So if any of us in the room or on the call were at this location and we were pedestrians and we're going to cross this intersection, where would we logically go? We're going to go to the truck apron and we're going to kind of skirt across the roundabout. I did it when it was built. We would all do the same thing. It's human nature. And that is not where we want our pedestrians, because that's what's going to happen, right? And that's not where we want our children. So build sidewalks at roundabouts. Always build sidewalks at roundabouts. Five Corners, Ellington, Connecticut. This was a 5-leg stop controlled intersection, which always stops are usually huge success rates for roundabouts. This one had terrible traffic congestion delay. Took 4 minutes to get through that intersection, just because of the delay involved with decision making with the 5 stop signs. Built the roundabout, got nice gateway features, worked very, very well. And overall, the traffic went away. You know, people were initially saying traffic was avoiding the area. It's not the case. It's just that the roundabout worked so much better. We reduced injuries by 70%. Crashes went up a little bit at this one for this data range. And that changes. The prior data range I had, they went down, but this one they went up 14%. But the benefit here is nobody's getting hurt, right? We reduced injuries by 70%, and it's still a safety success rate. So that was a huge improvement in terms of traffic operation and safety. This is one of my favorite roundabouts and one of our biggest successes. This one's in Salem, Connecticut, and this is typical for Connecticut, rural arterial roadway. This intersection's been built out over the years. You got turning lanes all the way around, high-speed tangent approaches. You know, you can imagine we're going to have some safety concerns here. And in the peak hour, trying to get through here was kind of the Wild West. There wasn't enough time for everybody, for every phase. People were making a left turn on the red, trying to fight their way through the intersection. This is what it looked like. I took this picture at 5 o'clock. And certainly safety concerns we have there in terms of how that works. Go to the modern roundabout, the speeds are low, right? 15 to 25 miles an hour. But you'll always notice here, we have concurrent vehicle entry. Multiple vehicles are entering the intersection at the same time, which you wouldn't have with a traffic signal. And that's why the roundabouts work so much better in terms of operation, in addition to safety. That's just wonderful how well the intersection works. Here comes a large truck. So anyone that might say trucks can't fit through roundabouts, absolutely they can, if properly designed. This one's actually a permit vehicle. That's an oversized load. The trailer's up on the truck apron, right where it should be. The cab of the truck's on the circular roadway. That's designed very well. And that's exactly how a truck should use a roundabout. Working wonderfully. Reduced injuries 88% at this location. And why that's such a big deal, the signalized intersection had 22 crashes a year with almost 9 injuries. Almost 9 people a year were probably going to the hospital at that intersection. We got that down to 1. That's lives saved. That's a big impact to that community. You know, that's somebody who went on with their life and didn't get hurt. Big deal.
And it just have, okay.
Well, I'll hit questions at the end. I'm gonna pick up because I'm running out of time, but Seymour, Connecticut, old rotary, right? High speed, possibilities through there. We go to the modern roundabout, much safer. We got pedestrian infrastructure there too. Just, you know, better intersection. If you look at this, you just can't go fast through this intersection. We're influencing driver behavior with the design of the roadway. And this is just the way to go. This was a huge success as well in terms of safety. Reduced injuries 93% at that location by upgrading that to modern roundabout features. Monroe, Connecticut, Route 10, 111. This was side street stop controlled. Very high speeds, a lot of delay at the stop controlled intersection. The people pulling out the stop sign on the leg with the stop, they just had a hard time judging gaps because of the approach speeds, and it resulted in a lot of traffic congestion. So we went to a modern roundabout at that location, a huge win for the community. You know, we reduced speed significantly. We got nice pedestrian infrastructure, and the delays completely went away at that intersection. That was a huge success. And I threw this in here just to show the benefits of uplighting and the importance of uplighting at that intersection. And that's a safety feature. Now, in today's world, I would not put in a tower that big in the middle of the intersection. That was done back in 2015. We know more now than we did then, but I still recommend something smaller, like a flagpole, small caliper landscaping, things that give vertical strength, but are not a significant concern for somebody that runs off the road and may go through it. In Connecticut, several of our roundabouts have had vehicles go through the center island. You know, you have people that are impaired, people that aren't paying attention, people that fall asleep. So whatever you put in the center island, be aware, it's possibly going to get hit at some point. You're going to have to replace it. So you don't want decorative statues or ornamental things. This is how we control speeds, and we validate speeds with our radiuses through the design process. R1, the entry, 24 miles an hour, circular roadway, 17 miles an hour. You know, I know that's going to be safe. Now, something I want to point out on the exit speed, it's 31. So that violates the 25 mile an hour recommendation in the manual, but I'm okay with that. As a matter of fact, I endorse it. What this is called is a tangential exit. And why I like this is when the driver's going through the roundabout and they go to exit, their eyes are lined up with the crosswalk. Their eyes are pointed toward the crosswalk as they decide to exit. If you see an engineer that decides, well, I'm trying to control speed, and they're over conservative and they put a hard right hook on the exit, what happens is that vehicle in the circular roadway has to slow down to turn right and crank the wheel to exit. And then as they turn right and crank the wheel, what happens? There's a pedestrian right in front of them and they weren't looking at that pedestrian. Surprise. So tangential exits avoid that, and I recommend that. If you're going 17 miles an hour in the circular roadway, you're never going to get much over 20, 25 by the time you get to the crosswalk. Grade, very important. 4% max per the manual, and there's a reason for that. If you look at that truck on the top left corner, look at the lean on that box truck. So you can imagine how easy it would be for a truck to flip if a truck has a liquid load that can shift, going to change the dynamics of that vehicle, and you have a steep grade, you can have truck rollovers. And where that comes into play is on the left turn. The through movements on the roundabout won't affect them, but when they try to make the hook on the left turn, they're going to have that problem. So don't exceed that grade criteria that's in the manual. This is what you want for your roundabout. Let's see if this plays. This video is sped up for time. You can see the school bus go through. Here's the truck. Rear wheels are going to go up on the truck apron just like it should. Cab stays on the circular roadway. Here's the school bus again. Anything with passengers goes on the circular roadway, not the truck apron. That works beautifully. 60% reduction in injuries. Now, a note on curb ramps. Use tapered or flared curb ramps at roundabouts. Do not use these vertical curbs on the top left. And the reason is, when that plow driver's coming in at night and it's 2 o'clock in the morning and there's 3 inches of snow and he's tired and he's trying to navigate his truck through this curvilinear design and get into the roundabout, if you use that design on the top left, there's a very likely chance the edge of that plow is going to contact that vertical surface. When you use those on tangent roadways, it's not a concern. The plow just goes right by it. But on a curve, the plow is going to contact that vertical surface. You can bend the plow, you can bend the plow frame, you can injure the driver. So use the flare, the tapers, the plow just rides up them and bumps right off. And your public works folks will appreciate you. On the truck apron, granite curbing, 2-inch elevation, mountable. On the back, I like 6-inch because it does deter trucks a little bit. On the left side on the approach, I like a 4-inch mountable curb. The reason for that is so emergency vehicles or tow trucks can mount the center island on the splitter as they're approaching. And if you have a crash on the approach, they can go on the opposite side and get into the roundabout and take care of business. The right side, I like a 6-inch curb because it helps with traffic calming and slowing vehicles. Now, I recommend granite anywhere there's curvature. This is what happens when you build concrete curb at a roundabout. This curbing's been in maybe 2-3 years when I took this picture. It just does not hold up to plowing. The plows bump it, they ride against it. You don't get good strength out of concrete curbing poured in place in the field. If you can get it precast, you'll have a decent product, but poured in place, first thing happens, that truck shows up at the job, the foreman's going like this, add water, they spin it, you just blew out the water cement ratio and weaken the mix. The next thing that happens is it doesn't get burlapped and wet, it doesn't get appropriate curing conditions. The strength on this curbing is not what we think it's gonna be per the specs, and that's what happens after you plow it a few years. Here's that truck, coming through. I put this in here as a recommendation for your center island materials. I like to use concrete and it's held up very well. 20 years, the concrete's still there. It's expensive, but it's still there. You don't have to replace it. If you start looking at lesser materials, just keep in mind when the truck goes through that roundabout, the rear wheels are not rolling. That tractor, the cab part of the truck, it kind of jerks and yanks those wheels to the side. They slide a little bit, and that's why there's tire tracks on that truck apron. That rubber is kind of getting angled a little bit. It's not a straight shot. So my point is there's a lot of stress on the truck apron as those trucks are navigating through it. And you want to use a very stout material to ensure you don't have to be back out there replacing it. Stage construction plans are a must for roundabouts. Absolutely. You cannot put a job out to bid without figuring out how you're going to manage traffic and how you're going to stage it. Because that truck apron was for the rear wheels of the truck to get through. What happens when it's not there or the concrete is green and not suitable for traffic yet? Well, that means you need a bigger area around the outer perimeter of the roundabout, which means you don't put the nose of splitter islands on till last. You don't build your sidewalk till last. Those are the last things to get done. So staging plans are critical to the success of a roundabout job or detour. Now, Granby, Connecticut, 202 Notch Road, high-speed rural arterial, side street stopped. Knew that was a great spot for a roundabout, showing how that would work. Obviously, you're going to have slower speeds with this type of intersection, and definitely a huge safety success there. Here's the school bus. Stays off the truck apron, really critical for that design. Anything with passengers stays on the circular roadway. So for folks worried about children, and the bus, worked very, very well. Less conflict points, slower speeds, 78% reduction in injuries after we opened that one. Huge success. This is in Guilford, Connecticut, and this is a really awkward configured intersection, and that's where roundabouts really thrive, right? Very confusing intersection, high speeds. Put the roundabout in there. We know that's the right choice, the safer choice for sure, right? Look at that. I mean, that's how you want to go. Here's traffic going through there, concurrent movement on multiple legs. That's capacity, that's efficiency. You wouldn't get that with that prior intersection. So we know that's a success. 43% reduction in injury. That one's fairly new. I think we're going to have better success when I redo the crash data on there. So a quick mention of other types of roundabouts. This is called a mini. The roundabouts we talked about so far, those are single lane roundabouts. This is a mini roundabout. This has a flat center island. Everything is mountable, including the splitters. This is not the same thing as the single lane roundabouts we were talking. Minimum diameter of a single lane roundabout per the manual is 120 feet. You can build them down to about 110 feet and still have a central island. Once you get less than 110 feet of area for your roundabout, now you're into a mini. What we see here, no speed control at all. We have no vertical features in the center island that slow traffic. We have no curbing. We don't have the double yield signs to help with speed control here. And my point is, these get used in areas with low speed context, which means there's something else in the area before you built your roundabout that controls speed. Because the roundabout here does not control speed. These are for downtown areas with very low speed conditions, not rural arterials, absolutely not. Now, if your roundabout gets to the point where you need to add additional lanes and one circulating lane or approach lane doesn't work, once you get to the point where you have 2 circulating lanes and 2 through lanes, approach lanes, stop. Think about what problem we're trying to solve. We don't want to put in roundabouts because we love roundabouts, we like roundabouts, that's why we're going to do it. We're putting them in to solve a specific problem. And just recognize conflict points go up the more lanes you add. This multi-lane roundabout has 24 conflict points. The single lane roundabout I showed you has 8 conflict points. A traffic signal was 32 conflict points. This is getting pretty close to the same conflict points. Now, the speeds will be a little bit less than a traffic signal for sure. It's going to operate significantly better in terms of capacity and traffic operation. But just be aware, it is not the same thing as a single lane roundabout that we talked about with the success rates previously in crash data. Look at the picture to the right. In the off-peak hour, how's someone going to drive that? Straight through, right? They're going to drive right over the striping. You look at the picture on the left, you know, and that would be our plan. You've got this nice curvilinear geometry going through, right? It looks like people are going to go through slow. That's not the case. The off-peak hour, they're going to drive straight through right over the line striping. You're going to have 40 miles an hour through that intersection. So just keep that in mind if you get to that point. These roundabouts often have more property damage only crashes than the signals they replaced. The injuries go down significantly, especially fatal crashes, so there's that benefit, but property damage only crashes are a concern with this. Now, all the things we talked about with roundabouts and my message, right? Don't wing it. Close enough is not good enough with roundabout design. Pay attention for the small details because they matter. Here's one in California. We don't have double yield signs. We don't have vertical strength center island. We don't have splitter islands on the approach.
It's like a scene out of a
All
movie
the
or
things
something
that
out
we
of Dukes and
talked
Hazzard.
about.
The woman
there.
drove straight into that roundabout. Definitely wouldn't.
So my point is the details matter. They do. Here's another one in I think this is North Carolina, but just another example.
Now hoping people slow down before
people can't see it coming up the hill either way.
This is a mini. It's at the crest of a hill. You can't see it.
become deadly.
Well, it's just like I thought it would be.
Twice, or even 3 times. And yes, it was captured on video. A few weeks ago, someone split a nearby telephone pole in 2.
Main problem is the roundabout.
All right, here. We move ahead. Summarizing our success rate here in Connecticut, fantastic success in terms of injury reduction with our roundabouts. Everyone has been a success. The one on the bottom was designed by Beta Group in Hartford. Fantastic success rate on that too. We're right in line with what Federal Highway is suggesting. And overall, we're reducing injuries by 71% and crashes by 47% with our roundabouts. And remember Mr. Wheeler, right? He was our aggressive driver. He's going to split the lanes in the multi-lane roundabout. And Mr. Walker, he was our vulnerable user that we need to design for and think about. So, question.
Well, just going back to what I was going to ask about the one in Salem. The one concern I have with you having the 2 lanes enter in 2 spots is, especially northbound on 85, they tend not to stop. They think they have a clear shot going through there. So I guess the question is that a less desirable solution for a roundabout? Like just keeping them 1 lane as opposed to having those multi-lane entries?
Absolutely. It's significantly more desirable than the traffic signal was there.
No, I won't doubt that.
But yeah, our priority would be to just have a single lane approach.
Yeah.
Always a single lane approach. And the design practice you want to do, we usually design for 20 years in the future, projected volumes. So we try to get it to work for 20 years in the future. On roundabout design, it's often recommended you might look 10 years in the future with an option to build the additional lane in the future if you actually need it. So when it comes to turning lanes or additional lanes, if you can get by 10 years post-construction with a single lane on the approach, strongly consider it. And then accommodate in your constructability future expansion, if possible. Because the more lanes you add, the drivers tend to split the lane lines and the speeds go up.
Well, again, my biggest concern there is you're not deflecting some of the traffic enough to slow them down. And unfortunately, the driver has the impression that they can go straight or continue through it.
Northeast drivers are not respecting lane lines. That's what happens, right? We talked about that
Yeah.
and the off peak, if it's really busy, they're gonna stay in their lane, but if it's the off peak and there's space,
Yeah.
they split the lines and they speed up. Any questions on the chat?
No questions in the chat.
Anybody else in the room?
Actually, Scott, excuse me, I was typing one, sorry. Awesome presentation. There was so much useful information and advice in the previous. I think maybe you had hosted one, I'll say 2 or 3 years ago, but this one was really awesome. I appreciate all the information. Is there a way though? We're trying to, we did try one and we've had mixed results on it, where it's kind of like a hybrid between a regular roundabout because we were limited to it right of way and we're limited with funding versus a mini roundabout. But then with the mini roundabout, like you pointed out, there's trucks, there's landscaping trucks and stuff like that. Is there a resource or how do you determine, whether you need the bigger roundabout or is there a way to?
My advice is
Yeah.
you always need the bigger roundabout. Your
Oh, okay.
single lane roundabout is the go-to. You start there. That's 120-foot diameter. What they recommend is the minimum. I can tell you from experience in laying out WD62 turning templates, you can go to 110. That will work. If you go below 110 feet, there's no opportunity for center island, and then you're into the mini. The mini is not desirable. There's no vertical features. You don't have the curbing. You don't have the double yield signs. That's for an extremely low speed context, a neighborhood circle, a shopping center, a downtown municipal area with adjacent intersections that control speed, other features that control speed, geometry that control speed. Your go-to roundabout is always a single lane, 120, 30, 40 would be the diameters you look at for the first. And then if you do the capacity analysis, you start adding lanes where needed. If you don't have space for 120, then you go down to 110, see if you could squeeze it in maybe and cheat. And then if you're into a mini, well, that's because you can't fit the single lane roundabout, which is most desirable. But my advice is if you need right of way and you have the opportunity to acquire it to build a single lane, you buy the right of way. Don't cheat the roundabout design.
Yeah,
Once
I think we tried.
you can't put it back in the box after you build it.
Okay, thank you.
Traffic signals and typical signalized intersections, we got in the habit over the years of tweaking them. There's things we could do. We can add a lane pretty easily, just widen a little on one side or the other. You can't do that with a roundabout. And when you add a lane at a traffic signal, we don't have safety consequences. Sure, you can add a left turn lane, a right turn lane later in the design. Doesn't have safety consequences. At a roundabout, if you add lane, conflict points go up, safety goes down.
Yeah, thanks. We just get a lot of pressure from, bike and ped groups with the mini roundabouts, that's why I was asking too.
The single lane is what you want.
Yep.
And what they want. And when it comes for bike advocates, we get a lot of requests for a bike path around the perimeter of the roundabout. I don't like it. We do it when we're asked, and we always put the sidewalk there, and we'll expand to a shared path when we need to, especially if there's a trail in the area. It's not my preference, and the reason is now you're putting people into the crosswalk that don't have to be there. So a bicyclist that would enter the roundabout with traffic, ride through the circular roadway, he's never crossing in front of vehicles entering the roundabout or vehicles exiting the roundabout. Once you put them into the crosswalk area or adjacent to the crosswalk, vehicles are entering the roundabout. They've got to run across that path, and vehicles are exiting the roundabout, which is a potential conflict where the cyclist is going to be. So you just added conflict points to that cyclist path by taking them offline. It initially appears it's a safety benefit because they're out of the roadway, but now you've added conflict points with cars that are not there if they stay in the circular roadway.
All right, do we have any more questions?
Yeah,
Maybe
I had a
about-
quick question. Sorry.
We-
Uh,
we do-
For
Go
the
ahead.
slide where you're talking about the exit speed being higher than 25, you were okay with that?
Yes.
If you could go back to that, and I thought it looked a little bit like the alignment offset to the right, and I wasn't sure if I was misseeing that, or if you could explain.
So what happens with the alignment is the exit alignment would be offset to the right, not the entry alignment. And what happens is the exit offset.
Sorry, I'm not sure which slide that was.
The remote goes back pretty slow.
Yeah.
Let's see, it had a lot of this one.
This one.
Yep. So we're looking at the exit where it says R3 31 miles an hour. And that's got a very flat radius on it. And that's what I'm calling a tangential exit. You know, your radius coming in gives you 24 miles an hour. That's possibly like center aligned is what it looks like. We got 17 miles an hour on the circular roadway. And my point is, if the vehicle's going 17 miles an hour max, right, based on the geometry, a reasonable driver, that's the best they can do. How fast can they possibly get at the crosswalk? 25, maybe? You know, you're just not going to get to 31 miles an hour in that extremely short distance. And why I recommended the tangential exit is pedestrian safety. So that vehicle that's circulating this circular roadway, when they get to the exit, they're looking straight ahead. The operator's looking straight ahead. What you don't want, and sometimes over conservative roundabout designers will put a very hard hook at the exit. So think about you're driving the car, you're in the circular roadway, you're circulating around the roundabout, you're cranking the wheel, and you want to exit. And then all of a sudden you got to crank the wheel hard to the right to exit. And as you turn to the right, there's a pedestrian coming off the curb ramp right in front of you. You're not looking at the pedestrians if you have to turn the wheel hard to exit the roundabout to the right. So, and the other thing that happens in those types of designs, people tap the brake. They're in the circular roadway, they're going around, they want to exit. If you make the radius too sharp, they got to tap the brake and turn right. And then you end up with rear end crashes in the circular roadway and the roundabout. It causes turbulence.
So that's a question. So the pedestrian and the crosswalk associated with a roundabout, cars are required to stop?
Yes.
It's not treated like
Yes.
a.
Yes.
So they would.
Required to stop, but
Yes.
that means the driver's attentive, his eyes are on the pedestrian, he can
Hopefully
see
attentive,
them,
yeah.
right? But as practitioners here, I'm letting you know with the tangential exit, when you're circulating that circular roadway, your eyes are going to be lined up with the crosswalk. If you had to crank the wheel hard right to turn to exit, you're not going to see the pedestrian until you're into your turn and you're almost on the crosswalk. So it's a safer design. Although the speed appears a little higher on what is possible, the reality is you can't get that speed. You know, it's a straight exit, but because of the 17 miles an hour on the circular roadway, you can't get that far. Now, I would be concerned about that if that R2 was 25 miles an hour. That would be a problem for me because you could get to 31 miles an hour at the exit. But so hopefully I cleared up that question.
Yes, you did. Thank you.
Okay, I see one more hand. We'll have to be very quick. And
Yeah,
then-
recently in West Hartford, there was a news story about what appears to be a mini roundabout. What could be done, what could have been done to prevent that sort of issue from happening?
Okay.
People were driving right over the roundabout and.
I have to be clear, Connecticut DOT was not involved with that roundabout. It appears to be a municipal design. I don't have a lot of knowledge on it in terms of plan review or anything, except what I've seen on the news that you all have seen too. And if you thought about the presentation I did today and critical design features we talked about here, especially with minis, we talked about splitter islands on the approach. We talked about community education because that was one of the things that the neighbors were talking about. They didn't understand how to drive the roundabout. You had vehicles coming in, driving right over the center. You know, they weren't yielding properly. So community education and outreach especially, but additional traffic calming in terms of raised splitter islands. Maybe it could be optical pavement markings to help reduce speeds on the approach, but things of that nature. And ultimately, like I mentioned, a single lane roundabout would be my preference with a raised center island. Now, once we decided that didn't fit, then we start looking at the mini as the less preferred option. Maybe that was done,
All right. Thank you so much, Scott, for all of your wonderful information today. If anyone has any additional questions, you can definitely send them my way and I can pass them along. This recording will go up on the NVCOG YouTube page. And lastly, our next Lunch and Learn will be January 14th. By request, it'll be on the state local bridge program with Andrew Shields from CTDOT. So we're very excited for our next Lunch and Learn in the series. Once again, let's give a hand to Scott. Thank you.
Yes, thank you very much, Scott.
You're welcome.
Thank you.
Thank you.